morning, dear students. And at this point, I hope that you all have a clear idea about different steps and process that is happening in translation. Uh, with the last class, we finished all these steps in the translation. And today I am going to explain some other phenomena that we need to understand in connection with the translation. First one is frame shift mutation. Mutation, what is it? We all know that mutation means it's a sudden heritable change in any of the property because of so many external factors. That is mutation. Then what is frame shift mutation? Frame shift. A shift is happening in frame. What frame? Reading frame. And that mutation I am going to explain you. First, it is the most deleterious mutation, most dangerous mutation. And it is most probably a single base mutation. It is a change happen in single base, and that change can happen because of an addition or a deletion. Okay. First, I am going to explain that effect by taking the example of a deletion. Okay. Then look in this mRNA sequence. It is a normal one. We all already have learned that three bases constitute one codon. By that way, AUG first codon, GAG second, CCG, and so on. And that normal mRNA undergoes a point mutation, a single base mutation. That means I already told you that I am explaining the mutation by considering a deletion type. So here in the CCG, one C is deleted. Here we can see that. So after this GAG codon, the codon is changed. Now in normal mRNA, the mRNA that need to produce the normal protein, in that the codon is CCG, but here it is CGA. It is changed, and that change is not stopping here. It is continuing downwards or downwards to all the other codons that we can see here. Here CCG, then AUU, again UUG, like that is a normal. But because of that single base change, deletion, this codon has changed, CGA. And the next one also changed. It becomes UUU. But here it is AUU. So that means from the point of that mutation onwards towards the downstream, the whole reading frame is changed. An incorrect reading frame is forming. Okay, and because of that incorrect reading frame, what would be the condition of the protein formed out of the mRNA, that mutated mRNA? That is not a normal, it's an aberrant protein. And that protein formed because of that abnormal amino acid sequence. That also resulted because of a point mutation. Such type of mutations are called frame shift mutation. I hope it's clear to you. I explained with the case of considering a deletion. Addition also can result the same effect. Okay, that is frame shift mutation. Next is about effect of antibiotics in protein synthesis. What is the effect the antibiotics is causing in protein synthesis? We are understanding that by taking the example of streptomycin. Streptomycin is an antibiotic, and what it is doing? What is its effect? Suppose a host cell can be a cell in human body, whatever it be. And that cell is infested by a bacteria. Okay, and as it is subjected to streptomycin, what happened? That streptomycin enters this bacteria's body and affects its ribosome by binding with it. Ribosome's small subunit is affected because of its binding. And what results? The mRNA that get translating with the help of that ribosome is misread from the from a particular point, and because of that misread, it results in a aberrant or abnormal protein that leads to the uh, death of that, destruction of that bacterial cell in the host cell. In that juncture, it is genuine to have such a doubt that why that streptomycin can't infect the host ribosome also. No, the streptomycin will not affect the host ribosome. That host cell's ribosome is not affected by the streptomycin. Because of that, it will not be affected and it can remain intact. Okay. In some cases, because of some changes in the ribosomal proteins, especially the protein estol, that bacteria become resistant to streptomycin. As it gains that resistance, it becomes impossible to destroy that bacteria using this antibiotics. Okay. That is sometimes happening. You have read it from so many sources that bacteria are now developing resistance to antibiotics. Okay, anyway, this is the process how the antibiotics kill a bacteria or destroy a bacteria in the host cell by impairing its protein synthesis. Okay. Then eukaryotic elongation factor. I need to mention that point to all of you now, because this is the only change, only difference when compared with the prokaryotic translation, elongation, and termination steps. The initiation step only a slight difference exists between prokaryotes and eukaryotes. All the other processes are almost similar. Only difference left with the type of elongation factors. In the case of prokaryote, the elongation factor that is helping in amino acyl tRNA selection is EFTU. I think you all are remembering that EFTU is the elongation factor that is helping in amino acyl tRNA selection. At the same time, in the case of eukaryote, the difference lies here. Here, that elongation factor responsible for amino acyl tRNA selection in the case of eukaryote is not EFTU but eukaryotic EF1 alpha. That is one difference. And coming to the next difference that lies in the elongation factor that is helping during the translocation process. In the case of eukaryote, it is eukaryotic EF2. Okay, but in the case of prokaryote, that function is done by another elongation factor called EFG. I think you are remembering that. Okay, that is the only noticeable difference between prokaryote and eukaryote with regard to which steps, elongation and termination steps. Okay. Next, we are going to see another phenomena, that is mRNA surveillance. Surveillance means something is observing very closely to check is there anything happening wrong. So that is surveillance. And because of the surveillance, No nonsense allowed. We will understand as we go through these points. What is nonsense mutation? We need to understand. No nonsense allowed. So, for understanding that, first we need to understand what is nonsense mutation. Nonsense means because of that particular mutation, certain stop codons are inserting within the coding sequence, within the reading frame. As a stop codon comes within the reading frame, what will happen? Uh, Actually, the stop codon should come only at the end portion. If the stop codon came somewhere here, what will result? The translation stops here. Stops here, and the rest of the codons will not be read. So that is the effect. Nonsense mutation. And because of mRNA surveillance, such type of mutations are not allowed. It will be prevented. How it is preventing? And we will go and see. And this type of nonsense mutation is responsible for around 30% of inherited disorders in man. Okay, then there exists a surveillance system to prevent the nonsense. Because of that, that particular defective mRNA get translated only once. After that, it get destroyed. It is selectively destroyed by a pathway called nonsense mediated decay, NMD. Then we are going to see that method. Suppose this is an mRNA having a stop codon inserted within the reading frame. Okay, first some spliceosomes are working here and remove all the introns and joining all the exons. And because of that joining process, they arise so many exon-exon junctions. And on that junctions, some proteins come and attach. They are called the exon junction complex. In all these junctions, that exon-exon junctions, that protein complex assembled. Okay, then later the ribosome is coming and start to translate or to read that mRNA. And during its process of reading, as it passed through the mRNA, it dislocate that exon junction complex. And as this mRNA has a stop codon inserted somewhere here in the reading frame, what happens? The ribosome misunderstand that here is the point to stop translation, and it stops the translation here and dissociated. Okay, then what happens? The protein result out of this process is not normal, and we need to distract this mRNA. How can distract this mRNA? This improper mRNA is still having some more exon junction complex in the downstream exon-exon junctions. Why? Because ribosome get dissociated from this point without removing all the other exon junction complex that is located downstream. So that becomes an indelible mark to point out that this is the mRNA, is the abnormal mRNA, the cell need to damage, destroy it. That is an indelible mark. And on recognizing that indelible mark, that mRNA is enzymatically distracted. That is a surveillance. So because of that surveillance, that improper, defective mRNA get translated only once in the cell. Okay, I think it is clear to you. Okay. Next, we are going to understand about polyribosome. What is polyribosome? The first we need to understand is definition. It is a complex of ribosomes invariably attached to the mRNA. This mRNA, a stretch of ribosome is attached with this mRNA and carrying out the translation. Okay. Uh, this is the first ribosome. This is the first ribosome binds with the mRNA and started to translate this mRNA from 5' to 3' direction. And as it moves a certain number of codons forward towards the 3' direction, the second second ribosome comes and binds. And as this one moves to a certain codon, certain distance forward, the next one come and bind in an array that goes on. And this result in the simultaneous translation of same mRNA. So, because of that, there will not any shortage of that particular protein that need to be or that get translated from this mRNA. That is polyribosome. Okay, I think it's clear for you. With this, we can finish today's class and section here. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.